Hello everyone, this is Shruti Saxena Das, and in this video we are going to discuss about lossless techniques for data compression. In the previous video we have already discussed about data compression, the types of data compression, and we discussed that what is the difference between the types of data compression. So we discussed that we have either lossless compression or lossy compression. So today we are going to discuss about the techniques which are used in lossless data compression. In case of lossless data compression, the data is not lost. That means that the exact replica is created after compression, and this is more common for the text compression, and we generally remove the redundant data for this one to achieve the goal, which is to maintain the exact copy, to get the exact replica of the original data after compression. Okay, so we are going to discuss this thing, but before that you can see the definition of lossless compression. So it compresses the data in such a way that when data is decompressed, it is exactly same as it was before compression. So here in this case, the decompressed data is same as original data. So the first method which is used for lossless compression is run length encoding. In case of run length encoding, what happens that this method replaces the consecutive occurrences. First of all, you need to find out the consecutive occurrences of any symbol. Okay, each character will be treated as symbol, and we need to calculate the number of occurrences. That means the frequency for each symbol. Okay, so it replaces the consecutive occurrences of a given symbol with only one copy of symbol. And we need to represent the count of how many times that symbol occurs. So we need to represent the symbol one time, and we need to write along with that symbol, we need to write the count of how many times the symbol occurs. Okay, so what we are going to do in run length encoding, what we are going to do, first of all, we need to check for the number of occurrences for every symbol. And what we are going to do, each symbol will be replaced by that symbol along with the number of occurrences of that symbol. Suppose the data which we want to send is in this form. Okay, this is the form. Now you can see each symbol. First symbol is A, second symbol is A, third symbol is A, then B, B, C, D, 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 like that. So this can be replaced by, see, here A is coming for 3 times. You need to check for the symbol, and you need to check for the number of occurrences that is occurring. Okay, consecutive, you need to remember this thing, that you need to check only the consecutive occurrences. Okay, one after other. So here you are getting 3 consecutive A. So what we can do, we can replace it by writing 3A. Similarly, here you are having 2 times B. So consecutively we have 2B. So we'll write it like this. Then C is coming for 1 time, so we'll write 1C. Then D is coming for 4 times, so 4D. So this number of characters, like this string of characters, we can replace it by using run length encoding method and represent it like this. Okay, see, here the problem is that if there is not a lot of repetition, like here in this case you are getting 4 times D, 3 times A, but suppose there is not a lot of repetition in data, then in that case it can increase the size of the file. Okay, unnecessary you have to write, instead of writing C, you are writing 1C. So like that, if suppose A, B, C, D, all the characters are coming only for the single time, then you need to write 1A, 1B, 1C, 1D. So unnecessary, it is going to increase the size of the file. So that won't be useful for data compression. This is mostly used when you are dealing with the numbers. Okay, and when the numbers, suppose the numbers which you are using are only 2 digits, 0 and 1. Okay, if you are representing some data in form of 0 and 1, then this method is very useful. Okay, you can simply count the number of zeros, consecutive zeros, and you can mention it 0 and along with the count of how many times 0 is occurring. Okay, similarly for 1 also. So this method is more suitable if you are dealing with the numbers. The second method is known as differential pulse code modulation. Differential pulse code modulation. So in this one, what happens that first of all a reference symbol is placed. Okay, so first a reference symbol is placed. You need to select one reference symbol in this, and that reference symbol is placed. Then for each symbol you need to traverse the string, and for each symbol in the data you need to place the difference between that symbol and the symbol which you have chosen as reference symbol. So we place the difference between that symbol and reference symbol. Okay, so what we are going to do here, suppose the string is the same which we have taken over here. We have 3 times A, then 2 times B, then C, then 4 times D. Suppose this is the sequence of characters which we have to transmit. In that case, we need to choose first of all one reference symbol. Suppose you have chosen A. Okay, A is the reference symbol. Then what will happen over here, that the same string, the sequence of character will be replaced by, see what you have to do, first a reference symbol is placed, so reference symbol is A, so A will be placed. Then for each symbol, starting from the first one, for each symbol you have to write the difference between this symbol and this symbol, okay, which you have taken as reference. So A, the difference is 0. So 0, second traverse in the forward way, second symbol is A, again the difference between A is 0, again A difference is 0. The next one is B. Now the difference between B and A is 1. Okay, in your series of characters, B comes after A and the difference is of 1. So we'll write 1 over here. For the next B, it is 1. Then for C, we are having a difference between C and A as 2. Then for D and A, difference is 3. Okay, between A and D we are having B, C and then D. So 3. So the same series of characters can be replaced by this. Okay, we can represent it like this using differential pulse code modulation. So that was the second method. The third method, which is used for lossless data compression, is called dictionary based encoding technique. Okay, this is the third method. So this one is used. It is also known as Lempel-Ziv method, okay, or LZ method. Fine. See, now in this case, what happens that we need to maintain a dictionary of variable length strings. So you need to first of all check for the common phrases which will be used. So for those common phrases, you need to create a dictionary of the variable length strings which are going to be used as strings. So what we are going to do, that dictionary of variable length strings. Okay, basically the common phrases is built. Fine. And you need to remember that here it contains almost every string that is expected to occur in data. Okay, every string that is expected to occur. And whenever that particular string is encountered, it will be replaced by the particular index in the dictionary. When string is encountered, it will be replaced by the index in the dictionary. Okay, suppose for the string computer, the index is 500. Okay, index is 500. So in that case, each time this word computer appears, it will be replaced by 500. Okay, instead of writing computer again and again, what we are going to do? We'll replace it by 500. Similarly, the common phrases or the common string of characters which generally occurs will be saved in the dictionary along with the index value. So wherever that particular phrase is used, it will be replaced by the index which is given in the dictionary. So that is the method which is known as dictionary based encoding method. So here you need to remember that we need to create entry for almost every string that is expected to occur. Okay, so here instead of dealing with the individual character, we treat each word as a string, and the output will be the index value of the dictionary. Fine. So these three are the major techniques which are used for lossless compressions, and as you can see that these are used for text compression. And there is one more important technique which is used, it is known as Huffman encoding technique, that will be discussed in the upcoming video. I hope these three techniques are clear. In case of any confusion, you can write your doubt in the comment box. Thank you so much.